Welcome back, children. Again, in the phase of preparation method of amines, we are going to discuss about the preparation method of amines. It is the lecture number. If we are talking lecture number five, lecture number five for the preparation method Hoffmann-Bromamide degradation. So Hoffmann, that is the name of chemist. Bromamide means bromine plus amide we are going to use, and degradation means one less unit we will get as a product. So check it here. The reaction is RCONH2, that is your amide, bromine plus NaOH. In that case, RNH2, 1 degree amine will be formed. Byproducts Na2CO3 plus NaBr plus H2O. So example, let's talk about one example. CH3CO NH2. In that case, Br2 plus KOH. So in short form, it's called HBD degradation. HBD, Hoffmann-Bromamide degradation, and product CH3NH2 will be formed. One important point here you have to write: Br2 bromine, only 1 unit use, only 1 unit we have to use, only 1 unit of Br2 we have to use. That is the condition for Hoffmann-Bromamide degradation. Let's talk about the mechanism, children. HBD mechanism. Hoffmann-Bromamide mechanism. In the case of mechanism, we need R C double bond NH2, so 2 hydrogen, like that I am writing. Then NaOH we will use, Na plus OH minus. From here OH minus will approach one hydrogen, and hydrogen electron shifted to the nitrogen. So we are getting now we are getting now in that case we are getting R C double bond O nitrogen, and nitrogen is negative sign, and one hydrogen is attached here, Br2. So bromine unit we will use, it will work as a induced dipole. So one bromine unit partial positive, one bromine unit partial negative, because here nitrogen is having negative sign, so this will attach with the bromine, and electrons shifted to the another bromine. So what you are getting now, RC double bond O, and N, one hydrogen is attached, and bromine. Okay, so hydrogen better to write downside, one hydrogen is attached. In the next step, again 1 unit of NaOH, OH minus Na plus approach the hydrogen, and again hydrogen electrons shifted to the nitrogen. So what you are getting, R C double bond O, nitrogen is having negative sign, and bromine is attached. In the next step, that step will be RDS, rate determining step. That is important part here. So these electron shifted here oxygen electron shifted, then back bonding, and then R will leave. So from here we are getting oxygen double bond, carbon double bond, nitrogen and bromine is attached. Now that R minus will approach the nitrogen and bromine electron, this single bond electron shifted to the bromine and bromine will leave. So in that case we are getting oxygen double bond carbon, double bond nitrogen. Now alkyl is attached. In the next step, water will come. Oxygen is having lone pair. It will attach to the carbon species because carbon is having partial positive. Both sides electronegative atom attached. That is why. So in the next step, oxygen double bond carbon and these pi electrons shifted on the nitrogen. Single bond nitrogen. Nitrogen is having negative sign. Hydrogen is attached. 1 minute. So electrons shifted there. In that case, we are getting oxygen, double bond carbon, single bond nitrogen, nitrogen negative sign, and with carbon, water species attached, and oxygen is having positive sign. In the next case, positive sign of the hydrogen will be vanished by the hydrogen electron. So from here hydrogen is free, that will attach with the nitrogen simply. So in that case we are getting O double bond C single bond N H R, hydrogen is attached now, and OH. Now you have to remove carbon dioxide from here. So these electrons shifted here, then this will leave. Nitrogen is having negative sign, then hydrogen will attach. From here CO2 leave and your product RNH2 is formed. 1 degree amine formation is done. So you can take the screenshot. Then again I am going to explain the HBD process. In that case, first you are using this amide. Again I am explaining the process. What you are using? You are using this amide. OH will approach the hydrogen. These hydrogen electrons shifted to the nitrogen. Then this species you are getting. Then bromine will work as an induced dipole and one bromine unit will attach the species. Then again OH unit will come. It will approach the again hydrogen and nitrogen is getting again negative charge. Electron shifted, back bonding and alkyl will leave. That alkyl will approach nitrogen, bromine electron will be shifted, then one unit of water attached with carbon, then positive charge of oxygen vanished by the hydrogen, that hydrogen will be attached by the nitrogen, then you have to remove CO2. That is the complete mechanism of HBD. So thank you children. This is all about the HBD, Hoff-mann-Bromamide degradation. Any confusion you can message me, you can write comment, I will explain. Thank you.